The next speaker is Evan Perotti. If you are a defender, this is an awesome topic. Look at that. The topic is RPC filters. I hardly know her! Exclamation point. Let's welcome Evan.
Hey everyone, hope you can hear me all right. Hi, like you said, I'm Evan. My talk is RPC filter. I hardly know her. Just a few notes before I get into things. If you're interested in the slides, they'll be available on this GitHub link afterwards, so you don't have to worry about taking pictures. You can just grab the slides right off the internet. There's a QR code, and at the end of the talk, I'll have a bigger version that's easier to see. I also hope you appreciate my slides. I put a lot of work into making them look like Windows-related things. So kind of the impetus for this talk, there's this great series of tweets that I saw by Craig Kirby and Benjamin Delpy about blocking Petit Patam, which was a very popular network coercion attack. And the tweet chain basically mentions that you can use RPC filters to block this network coercion attack. And so that's really the motivating factor of this talk, is understanding what these RPC filters are and how they can be used to block network-related RPC attacks. Before we get into things, just a quick intro. My name's Evan. I work here in Philadelphia at a small consultancy called Security Risk Advisors. You may recognize the name. We have a public free tool you can use for your purple teams called Vector. So check that out if you do purple teams. My background is in offensive operations, so I did a lot of pen testing and then a lot of purple teams. Nowadays, I'm mainly focused on research and development. If you're interested in contacting me, you can obviously find me here at the talk later, or at the con later. I also have my Twitter here if you're interested as well. You can reach out to me with any questions or concerns about the talk or any other topic you might be interested in. I'm around. So the general structure of the talk that we're going to go through today is I'll give some background on general Windows RPC related information. That'll be the drier part, so bear with me. Then we'll talk about RPC filters, what they are, how you make them and implement them. We'll talk about how these can be used for defensive applications in security. We'll talk about some implementation specific details, so if you're looking to implement this in your environment, some considerations that you should think of, as well as some limitations of the technology, and then some closing thoughts. Just quick thumbs up if you guys can hear me all right. I'm coming through all right. Thanks. All right, so some background. You've likely heard the term RPC before. If you're not aware, it stands for Remote Procedural Call. Remote doesn't necessarily mean between two systems. It can be within both a local system within Windows as well as between two hosts over the network. It's implemented as a client-server mechanism, and it's typically used in Windows for different types of inter-process communication. So if you're writing in one program and you need to get information from another, you can use RPC to pass information between those two different programs. It's used extremely commonly in a lot of different legitimate Windows operations. It can be used remotely, like I said, with another network host, so over the network, and it's typically done over SMB name pipes or TCP as the most common ones. There are other transport that RPC can use within Windows, for example, Hyper-V. Some important concepts within RPC, if you're interested in looking into this, are interfaces and procedures. So procedures are the individual method calls that your RPC client will make to run whatever function it needs to. And then there are interfaces, which you can think of as kind of overarching groups that are collections of these different procedures. So to give a more concrete example, we'll consider the Service Control Manager within Windows, which I'm going to use a lot for all the different examples within this talk, because the Service Control Manager is a really nice, simple example that kind of exemplifies a lot of the topics we're going to discuss. So an example of a procedure within the Service Control Manager would be creating a Windows service. So something like an updater or something along those lines. And the way you would create this service through RPC is by calling this RPC procedure rcreateServiceW, which has every RPC procedure has its own procedure number or an opnum, and that's how you identify it from your client. And so if you take in aggregate all of the different Service Control Manager operations, like creating a service, modifying a service, starting and stopping services, these in aggregate make up the interface that is the Service Control Manager. So to dig down a little bit, this is what an RPC client server looks like. On the left, you have the definition of the RPC service, so it's defined by a unique identifier, a UUID. You define the interface as well as all of the different procedures that are involved with it. In this case, this test interface has a foo and bar procedure. And then you take this interface definition, convert it to your programming language of choice, and then you package it up in whatever application you're using. And so then when you go to use this as an RPC client on the right here, you basically just call the RPC procedure and you pass it the input parameters, and then the server handles it from there. And so if we take a deeper look into this right side here, this is essentially the lifetime of your RPC connection, where you have your client make the RPC procedure call with all of its methods, and then it essentially just says to Windows, this is an RPC call. And then the RPC runtime that's built into Windows handles pretty much everything else. It marshals and unmarshals all the data when passing between the client and server. It handles things like authentication and authorization and access checks. It handles mapping your RPC server so it can listen without you having to worry about it explicitly. And then once your client passes that data onto the RPC server implements the business logic that's related to that RPC procedure. So the Windows RPC runtime handles a lot of the back end and abstracts it away from you so that from a client-server perspective, it's very simplified. If you look at a lot of the different RPC interfaces within Windows, they're typically well documented in some capacity. So you can go out to Microsoft's TechNet to view the documentation for these, the descriptions of the RPC interfaces and the procedures that they implement, as well as the procedure numbers. So for an example, this is the Service Control Manager documentation here, and you can see the different procedures that the Service Control Manager implements. However, some RPC interfaces aren't necessarily going to be documented. So there's this great tool called RPC Investigator. That's an open source tool provided by Trail of Bits, and it can be used to investigate different RPC interfaces as well as the procedures they implement and the details of those interfaces and procedures. So you can go out to GitHub and download this. So for an example, using our Service Control Manager example from previously, we'll take the services.exe binary, which comes in your Windows installation, and load it into RPC Investigator, and we can see the different RPC interfaces that it implements here. Also keep in mind this 367 UUID. This is the Service Control Manager interface ID. It'll come up a lot during the slides. But then we can drill down into the specific RPC interface and look at the different RPC procedures that are implemented by the Service Control Manager. So here we see again our create service W, which is what's used over RPC to create a Windows service. And you can see all the different parameters that are taken by this RPC procedure, as well as the procedure number. And for creating a service, it's 12, so again, keep that in mind because it'll come up. But as you can imagine, RPC, because it is used so widely within Windows, it in some way relates or underpins a lot of different attacks that you see commonly in different types of environments. So some notable examples are things like DCSync and PSExec. And there's this great repository linked here, which you can check out later, which maps a lot of Windows RPC attacks to MITRE ATT&CK, as well as provide information about the RPC interfaces and RPC filtering. So definitely recommend checking that out, but I've summarized it here in this table, which is a big table of text, but I'll go through some highlights. So if you're familiar with some of these attacks, they should stand out. Things like Bloodhound, which is used for Windows domain enumeration. It'll do things like session collection about who's logged into different systems, as well as get logged in users, and it does this over RPC using the server service and workstation service RPC interfaces. There are some other notable examples, like a lot of the Windows coercion attacks, like the print bug, and like I mentioned, Petit Patam. They also use RPC interfaces. Petit Patam uses the EFS RPC interface. The print bug uses the print RPC interface. There are some other notable examples like DCSync, which you can use once you have privileged rights within the domain to extract users' passwords and other information about the AD object by using the directory service replication RPC interface, which is used by domain controllers to replicate information. So suffice to say, RPC is used by a lot of attacks, whether you realize it or not. To dig down into an example, we'll look at PSExec, which again uses the Service Control Manager. Like I said, it's a great example. So PSExec, if you aren't aware, is a tool that's part of the sysinternal suite. It's used for remote code execution in Windows environments. So you can use it to target a Windows system and run a command on that of some kind. It's typically used by Windows administrators as an alternative to something like SSH if you're looking at their Linux administrator counterparts. And this is because for a long while, Windows administrators didn't have a great mechanism for remote code execution like this. Nowadays, they have things like WinRM, which take the place of SSH and PSExec for Windows administrators, but PSExec for a while has been used legitimately by administrators to run commands and configure Windows host. But the way PSExec works is that on your client system, the system you're running PSExec from, the PSExec binary creates this PSExec service binary, which it copies to the remote target over SMB to the admin share, and then it uses the Service Control Manager RPC interface to create a Windows service that targets that PSExec service binary. And then it starts that new service, also using the Service Control Manager RPC interface to start the service, gets the output of the command and then pipes it back to your local client. So for example, if you run a command like who am I with PSExec against a remote target, the PSExec service will get created on the remote target. The who am I command would run under the PSExec service binary, and then on your local client, you get the output of who am I. Another way we can look at RPC, this is a great resource by Akamai as part of their RPC research, but essentially you can take the Windows ETW logs for RPC to get logs of RPC connections that have happened in the environment, and then you can map those in a graph database similar to how Bloodhound would map its relations so that you can visualize different relationships that are happening over RPC. So to take our Service Control Manager example, using a create service W, which is, like I mentioned, procedure number 12, you can see here this 367 RPC interface ID, that's the Service Control Manager, and you filter on that plus the operation number of 12, which is creating a remote service, and we get the result here of the relationship of an unknown host creating a service against this server 22 host. And so we can visualize and map these network attacks that are happening over RPC. And so in this case, this would be something like a PSExec style lateral movement where you're moving from one host to another by using the Service Control Manager. So we're going to talk about RPC filters next. But before we do that, there's two Windows components we should understand that tie to RPC filters. The first is the Windows filtering platform, and the second is the base filtering engine. So the Windows filtering platform is a mechanism within Windows that abstracts away a lot of the capabilities that are used to implement your own type of networking-based controls. So for example, if you're implementing something like a firewall application on your own, rather than having to write all of the back-end kernel logic to handle networking connections and blocking them, Windows provides this filtering mechanism for you to build on top of. So if you look at something like the native Windows firewall, it uses the Windows filtering platform to implement a lot of its control logic. And so that's how you do it. It's built into the kernel. And then the base filtering engine is a component of the Windows filtering platform that allows you to manage and store your filtering rules for your different applications. So if we take a look here at this diagram, the bottom left is essentially where you'd start, which is something like the Windows Firewall Management GUI, which is you as a user would interact with, and then that would talk with the Windows Firewall service. And then when you add your different filtering rules, those will go through the base filtering engine, and then from there the kernel takes over and it can manage the network blocks for you through the Windows filtering platform. Another diagram here, which it's very big, but really the only important thing you need to worry about is the right. So this is the Windows filtering platform architecture, and essentially what's important to note is that RPC connections are treated specifically. So there's specific handling for RPC within the filtering platform that allows you to get more expressive controls as part of your network filtering. So you can, beyond just the source destination IP imports, you can do things like trigger off characteristics of the RPC connection itself. And so that's where we start with our RPC filters. And so RPC filters are a mechanism for you to get firewall-like blocking capabilities for RPC connections. And there are a lot of different characteristics you can trigger on as part of your filters, But the thing to note with this is that when you're blocking RPC connections with RPC filters, it's all or nothing. So you either block the entire RPC interface or you don't block it at all. And this is just a limitation of the platform. So for example, if you want to block services, service creations, you would have to do it by blocking the entire service control manager with an RPC filter rather than specifically the service create procedure that's part of the service control manager interface. So that's an important thing to keep in mind, and we'll touch on it later. But for now, we'll talk about the kind of digging into the RPC filters themselves. And if you're interested in this, I definitely recommend this link here by James Forshaw. He's a very established Windows security researcher, but he provides a lot of background on RPC filters and how they're implemented within Windows. But the things you can filter on in an RPC filter are a lot. There's a lot of useful things that are filterable. And so I've listed some notable ones here, things like the interface ID. So this would be those unique identifiers that are tied to each RPC interface. Another thing to note is that RPC interfaces can be versioned. So you can have different versions of the same interface, and you can base filters on specific versions. This doesn't really come up much for a lot of the default ones that we're interested in, but just something to keep in mind, especially if you're dealing with third-party RPC interfaces that have been installed post-Windows installation. You can also filter on the networking protocol that's in use as part of the RPC connection. So like I mentioned, when RPC is going over the network, it typically happens over things like SMB named pipes or TCP, and you can filter on those specifically. So for example, you could block a connection that occurs over SMB named pipes, but allow ones that happen over TCP. You can also filter based on the authentication information that's passed. Because this happens in Windows, a lot of these RPC interfaces require some form of authentication before their authorization checks as well. And so you can filter on the different authentication types that were used as part of the connection. So for example, you can block connections that are using maybe a weaker authentication like NTLM and allow connections that are still using Kerberos. Another thing you can filter on is the user's token. So for example, if you want to filter on users that are members of a group, you can do that by allowing connections from users that are part of a group versus disallowing users that aren't part of that group. Lastly, you can filter on the name pipe itself. However, the reason I've stricken it out here is because from some empirical testing that I've done myself, it doesn't look like this is actually the case. I've built some filters that filter based on the pipe name, but they don't seem to actually take effect, so I'm not sure exactly what's going on here, but it is documented at least that RPC filters work on name pipes. So to create an RPC filter, the way you'll typically do it is through NetSH, which is the built-in Windows networking command line utility. It also provides an interactive console shell if you're using it. You can alternatively create the RPC filters by creating them programmatically, and Akamai, as part of the RPC research, has some example code on how to do that. But for the most part, we're going to be looking at how to do this with NetSH. And so effectively, the way you do it is by defining your rule, whether it's like a block or allow, and then the conditions of the rule, one or more conditions of how the connection should be filtered, and then you add it. And so breaking this down a little bit more, the first step, which is creating the rule, this is where you define the action of the rule, whether it's a block or allow. I also note audit here. Audit isn't an action, but it's tied to the action, and we'll get into that when we discuss auditing. And then there's a layer, which isn't particularly relevant for us. We're mainly interested in this user mode layer, but there's some other different layers depending on how the RPC connection occurs and in which parts you want to block the connection on. I recommend that James Forshaw article because he discusses in depth a bit more the layers, but again, they're outside the scope of our talk. And then after you define the action, you would define the conditions, and conditions in RPC filters are made up of 3 different components. The first is the field, which is the filterable field, the ones I just discussed, things like the interface ID, the authentication information, or the user token. And then the match type, which is the way that it's going to compare the field for the condition. This could be things like less than or equal to, different types of comparison operators. And then the data component, which is just the value that's being compared against whatever your condition is. So for example, if you're blocking the service control manager, you'd write a condition that would look at the interface ID and compare it to the unique identifier of the service control manager, this 367 ID. So looking at some example conditions of some common scenarios that will come up if you're looking to write RPC filters. The first is, like I mentioned, writing one for blocking based on specific RPC interfaces. So this would be for the service control manager. You'd provide the RPC interface ID, which is that UUID. You can find this, like I mentioned, with RPC Investigator. You can alternatively find it by looking at TechNet. It's typically documented there as well. And so this is the way you do interface-based blocks. Another thing you can do is basing it on the authentication. So for example, if you want to filter RPC connections based on the authentication for Kerberos, you'd look at the documentation for RPC filtering for the translation of how this authentication type is represented, which is as this 16, and then you put comparison of the auth type. And then lastly, if you want to write an RPC filter that looks at a user's group, what effectively you do is find the group, you'd find the SID of the group, and then represent it as an SDDL string here and compare it to the user's token. And so this filter here is checking that the user is part of this specific domain group. And so when you create it with NetSH, the RPC filter provides an ID. Every RPC filter has its own unique identifier, and it's stored in the registry along with some binary data. And when the filter is created, it gets that ID. Alternatively, when you create the filter, you can set the ID yourself, which is an important component we'll talk about. We talk about deployments, but the filters are stored in the registry as a parameter of the base filtering engine's service. So that's what this current control set is. It's stored under the persistent key. This is because the RPC filters typically persist through a reboot. However, you can have RPC filters that do not. They're more ephemeral, and those are stored in a different location. But for the most part, we're concerned about persistent RPC filters that will last for as long as we need them to. The binary format that these RPC filters are stored in isn't documented by Microsoft, but there is this great article here that goes into a reverse engineering of the structures used by the base filtering engine. So if you're interested in looking at that structure in more depth, you can read this. However, I'll note later that this isn't really a hurdle for us because we can work around it pretty easily. So this is end-to-end essentially of what it looks like under the hood. If you're creating these RPC filters, you have your client that is creating filter, the NetSH. It implements the APIs provided by the Windows filtering platform, and it uses that to interact with the RPC interface of the base filtering engine. So to make these RPC filters, you use RPC to interact with the base filtering engine. An important note about this is that the RPC server that's implemented by the base filtering engine that you use to create these RPC filters is local only, so it can't be called remotely. I'm going to do a walkthrough now of what it essentially looks like, start to finish, of creating an RPC filter and how it presents. So the first thing I did here is, the target is this .20 address, but the first thing I wanted to do is check the firewall status of this system to see if the Windows firewall is enabled. In this case, all the different firewall profiles are disabled. And so the important note here is that you don't necessarily need to have the Windows firewall enabled or on to make use of these RPC filters. They can work without necessarily having to rely on the Windows firewall. I know that's a big concern for a lot of folks who turn it off by default or implement some type of other firewall solution. Next, you use NetSH to drop into the RPC filter subcomponent. You provide the block type, and then you provide the condition again. We're just blocking the Service Control Manager interface ID here on this .20 target. And then when you are on a separate system attempting to interact with this system that has an RPC filter applied, say you're using sc.exe to query all of the installed services on the system, it would be blocked, and you get an access denied because the RPC filter has, in this case, blocked connections to the Service Control Manager. So RPC filters aren't all that commonly discussed. However, there have been some past defensive applications of them. One I thought was interesting was that Microsoft themselves, as part of their remediation guidance for MS-08, which is a very prolific SMB vulnerability similar to the more recent MS-1710, but they essentially state that if you're not able to apply the patch that they provide, one of the workaround solutions you can do is to apply an RPC filter for the server-server's RPC interface, and that effectively blocks the MS-08 attack. So that was interesting to note. Some other previous works, like I mentioned, the MSRPC to attack repo, which maps a lot of RPC-based attacks to MITRE ATT&CK, as well as provides RPC filtering notes for them. Wildly useful resource that I definitely recommend, as well as Akamai's security research. They've done a lot of recent work around RPC security in general. And then lastly, the RPC firewall, which is something I want to touch on now. So the RPC firewall is an open source tool provided by Zero Networks, and it implements RPC-based network security filtering similar to RPC filters, but it does it as an agent-based solution. But the nice thing about it is that it solves the all-or-nothing problem of RPC filters. So here's a comparison between them. The important one is the first one, which is that RPC firewall allows you to filter on specific RPC procedures for RPC interfaces. So this is wildly useful if you're looking to take a more granular and surgical approach to RPC filtering, because you can filter on just the procedures that are used by the attack rather than the entire interface itself. So to go back to our Service Control Manager example, with an RPC filter, you'd have to block the entire Service Control Manager interface, but with RPC Firewall, you can block specifically the rcreate_service_w procedure, and so that way you block just the minimal amount of procedures required to perform the attack. The downside is that you need to deploy their RPC agent, but it is at least open source. You can get it on their GitHub. All right, so the real reason I wanted to give this talk was that I had the goal in mind that I want to prevent different types of network attacks and lateral movement attacks by using RPC filtering and deploying it into my environment. And so I figured if you're going to go this route, there are likely going to be some common hurdles you'll run into. And I wanted to address those and propose solutions for them. And so that's what we're going to talk about now, are the implementation specific details of applying these RPC filters and making the most out of them that you can. And so the first hurdle is, how do you track these RPC filters, right? It's a blocking control. So how do I get effective auditing of them? And so the solution here is that you can use the auditing trick, which is something that I haven't found documented anywhere. To the best of my knowledge, I'm the only one who's documented it at this point. But we're going to talk about auditing of RPC filtering. So the issue with any type of blocking control, not specifically RPC filtering, but any type, say it's anywhere from like an EDR, blocking execution, or a firewall, is that how do you keep track of what's being blocked, right? You always run the risk with blocking controls of blocking legitimate business processes and in some way affecting production negatively. And so if you're going to go the route of blocking these RPC connections, which are used under the hood by a lot of legitimate Windows processes, how do you actually make use of them? Can you even audit these RPC filters and these RPC connections effectively? And so the first place I looked was the Windows event logs definitions, and I came across this 5712 event, which is documented as having been a log of when an RPC connection was attempted. And so this sounds great. This sounds like the type of things you'd use to audit your RPC connection. Unfortunately, if you read the TechNet documentation for this Windows event, Microsoft themselves say that this event is never cut. It doesn't write to the event log. And so you think, this is the end of the road, right? How do I get Windows events for RPC? However, if we look first at the NetSH documentation for RPC filters, one thing it notes is it has a section on auditing RPC filters. And it notes that when you enable auditing as part of the RPC filter, it should write an event for the RPC filter. And so theoretically, filters can be audited and logged somewhere. And if I'm a betting man, I'm probably thinking it's going to be either the Windows event log, or it's being written into some ETW channel somewhere alongside the normal RPC ETW events that get cut normally. The next piece of documentation I looked at was the advanced audit settings for group policy. And so one of the detailed tracking subsections for advanced audit is that it can audit RPC events. And it notes that it should audit an event when the RPC connections are attempted. So presumably, if you have this advanced audit setting enabled, you'll get some type of log. And again, if I'm a betting man, because it's advanced audit, it's probably in the event log alongside all the other advanced audit settings like 4688s and 4769s. And so what happens when we merge the advanced audit settings for RPC auditing and we enable auditing on our RPC filtering? Well, what we get is this 5712 event, which is supposedly never occurs. And it has a lot of relevant information for our RPC connection. It has the user that initiated this connection. In this case, it's a domain user called Puffin. It tells us the process that was related to this. It says it's an RPC event, 5712. And then it has all of the RPC-related interface information that's relevant to us. It has the interface ID. It has the protocol it went over, in this case, TCP. It has the authentication-related information. In this case, I believe it was NTLM. And it also has the source information of where the network connection occurred. And so this is hugely useful for any type of tracking. Unfortunately, if you try to make an RPC filter that is a blocking filter and you set auditing to enable, you'll get an error. And this is because fundamentally RPC filters do not allow the audit to be enabled for any type of blocking filter. When you set audit equals enable, your action type must be permitted. So realistically, if you're going to audit RPC filters, it seems like you can only audit permitted connections and not blocked connections. But then I had the idea, well, what if I make my rule the way I want to make my rule? It blocks the connection, and then I duplicate the rule. I make an exact duplicate, but I set the type to be permitted, and I set auditing to be true because that's the only way you can do auditing. And so I have a duplicate that essentially does the same thing. What happens? Well, what happens is that the connection is blocked by the RPC filter, but then the event is still written to the event log. So you get all of the benefits of the auditing and all of the benefits of the blocking by just duplicating the rules. And so this doesn't seem to be documented anywhere. I think I'm the one who discovered it, hopefully. That'd be nice. But hopefully you can make use of this to get proper auditing of your RPC filters. The order doesn't seem to matter. It doesn't matter if you put the block first or the audit first. It seems to work the same way. The second hurdle I wanted to consider was how do I deploy these RPC filters, right? From all of the examples we've shown, the way we're doing this is where we just have a local CMD open and we're using NetSH to create these filters. So how do I deploy this at scale in a corporate environment? And so there are a few different ways you can approach it. Like I mentioned, when you create the RPC filter, it gets written to the registry as part of the base filtering engine's service parameters. And so presumably you can just write these registry values directly using something like a group policy preference. Another way you can do it is by using NetSH, running NetSH commands through some type of GPO startup script. Or you can use one of those two options with some type of configuration management tool like Intune or SCCM to run those commands through that interface. And then lastly, another way you could do it is if you have some type of golden image process for deploying your endpoint images, you can bake the RPC filters into your golden image such that they're already there when the system is deployed. So for example, if you have your Windows Server golden image that gets deployed for all of your Windows systems in your data center, as part of your build process for your golden image, you would apply your RPC filters, and then when instances of that golden image are deployed into the data center, the RPC filters are already applied. However, there's some things to consider with these deployment methods. The first is with NetSH, if you go this route. One handy feature of NetSH is that you can effectively take all the commands that you would run in an interactive NetSH console and drop them into a text file and then target it with NetSH. So I can put all my filter rules in a text file and then target it with NetSH, and NetSH will run through all those rules and apply them for you. And so this gives you the ability to put all of your rules in a text file, put them on a write-restricted share like your domain sysvol or something else that you might use for deployments, and then as part of your GPO, you just have NetSH run against that share. With the registry method, assuming you want to write directly to the registry because you don't want to be running commands or maybe you don't have that kind of capability, the thing to consider is that you need to restart the system after you write to the registry. Otherwise, the base filtering engine won't see the rules that have been written directly to the registry. It needs some other component to refresh it. And so that just limits the usability of the registry method because you need the restart. Another thing I mentioned, when you create the rules, they're given a unique identifier for every rule you make. However, you can set the rule yourself. During the creation process, you can set the unique identifier of your rules. And so this allows you to get better consistency of management of rules across your environment. So for example, if you define all of your rules and you set the ID for every rule, when you go to interact with the rules on any individual host, they'll all be consistently named by the rule ID across all the different systems. So if you're looking at the rule on one system, based on the ID, it'll be the same on every other system because you can predefine the rule IDs ahead of time. And it also allows you to better manage them. When you're making updates to rules, it'll be tied to that specific rule ID. So I'm going to do some walkthroughs of what these methods look like in practice. The first is how to do it with the registry method. So like I mentioned, when you create the rules, the limitation is that the rules get stored in the registry in some weird binary format. However, what we can do is just make the rules in a test system and then export them from our own registry with something like reg.exe and then apply them anywhere else, because from my testing, it seems that the rules are portable. It doesn't matter the system that they're made on, they work the same regardless of what system they're applied to. And so here we have just a test system. It's stock domain joined. It's just a local VM. We create our RPC filter that blocks the service control manager. You can see at the bottom the 367 interface ID, and you can see it has a rule ID, this third underline here of A34. Then we can go into our domain controller, to our group policy editor, into the group policy preferences. We can take the rule ID, and that translates to the registry key value, and we set the value of this key to be the binary data that we exported from our local test system, and then we'd apply this in a GPO and restart the system after the GPO takes effect. And now here we see we're on a domain joined system, and we have the same rule ID, the A34, applied that applies the block against the service control manager interface ID. And so you can see that the rules are portable, regardless of being written in some weird binary format. The next walkthrough is deploying the RPC filters via a GPO mechanism, like a GPO startup script. So like I said, you can put all of your rules, effectively all the commands you would run via the NetSH console in a text file that we have on the right here. Is the first rule deletes a rule of the ID 72F, and then the bottom one adds a filter rule for blocking the service control manager, the 367 ID, and it's given an ID here of DD0, and I've just dropped it on the sysvol as well as a bat file that just tells NetSH to run this RPC filter rule file. And so once that's deployed via GPO and it takes effect on the system, so here is our startup script targeting the bat file that will run NetSH and apply the rules. You can also use any other type of execution primitive that's provided through GPO, something like a scheduled task you could create as well that would do effectively the same thing. But once it applies, now we're back on our domain system, and we can see that the rule ID that gets applied for blocking the service control manager interface, DD0, matches the one that was provided on the sysvol. All right, so the third hurdle I wanted to discuss is, what about legitimate use, right? Presumably some of these RPC interfaces are going to be used by normal, legitimate business processes. So for example, if you have, say, like a monitoring tool that's polling service configurations against hosts in your environment, it would realistically need to access the service control manager RPC interface to do so. And so how do you work around that while still blocking these attacks by the large majority of users? And so the solution here is that you can use the user token filtering of RPC filters to allow specific users to access those interfaces while blocking everyone else. And so I'm going to go through a walkthrough of doing that by making an RPC filter that allows members of a domain group to access that filter while blocking other ones. So the first thing you do is you define your Active Directory group. So right here we have on the top an Active Directory group called RPC allowed, and then you'll grab the SID of that, and then we'll take a look at the members of our RPC allowed domain group, and we have one member named Toucan, and so this is a user that you would set to be allowed to access the RPC interface. Then what you do is you would create a permit RPC filter that allows members of that domain group by the SID. So the SID here in this SDDL string is the same one from our previous slide for the RPC allowed group. And so that's given a permit action in our RPC filter. And then we apply effectively the same condition without the match and block it. So in both cases, we're filtering on the Service Control Manager interface, the 367 UUID. The first is the allow for the group member. The bottom is the block for everyone else. And so then if we try to use sc.exe to query a target that has this RPC filter applied, in this case, we're using the domain user Vulture, which is not part of the RPC allowed group, and they're blocked from access. You can see at the bottom, sc.exe is given an access denied. The top part is just during the sysvol to show that the credentials are working and valid for this user. However, if we then run it again as our domain user toucan, which is the one that it is a member of the RPC allowed group and part of the allowed RPC filter, we can see that we get back the installed services from sc.exe by running it against our remote target. And now this all sounds great, RPC filters sound great, but there are some limitations to be aware of. It's not a panacea. So I wanted to cover some of the more pressing limitations of RPC filters. The first is, like I mentioned, if you're looking to deploy RPC filters via the registry method, you need to restart the system after the changes to the registry have been applied. And this can be a non-starter for a lot of different systems. Some systems have very strict uptime requirements, so they can't necessarily be restarted for this to take effect. Or maybe you don't have a great method of forcing reboots on your systems. Maybe your end user workstations don't have a great way to do that. So this can be a non-starter for some folks. The second is the all or nothing issue. You can't filter on the specific procedure numbers of the RPC interface. You have to either block the RPC interface entirely or not. So that's where RPC Firewall makes for a great utility, as it allows that granularity. However, in some cases, these RPC filters realistically aren't used in a lot of scenarios. Like with Petit Patam, the EFS RPC interface isn't particularly used all that much, so it can be safe to block them. However, it's hard to know the entire impact of what the block is going to be because, like I said, these are used by legitimate Windows processes, so it's not necessarily easy to know, especially if you aren't performing the RPC filter auditing for these. You don't necessarily know which things in Windows are going to be blocked, and that can cause issues. So you really have to do a good job of running an audit pilot to understand what RPC traffic looks like in your environment ahead of time. Another consideration is that RPC filters only apply for remote connections. So these RPC filters, assuming, like I said, you can interact with these RPC interfaces both locally within the system as well as remotely against a system on the network, but RPC filters only affect the network case. So for example, with our Service Control Manager, if we write a filter to block the Service Control Manager, it'll only apply to users interacting with that remotely. If I'm logged in locally to a system and I'm issuing st.exe commands from a local terminal, the RPC filters will in no way affect those activities. The other is, like I mentioned, with the base filtering engine RPC interface, the one that's used to ultimately implement the RPC filters, is that it's a local-only RPC interface. What this effectively means is that if you're looking to deploy RPC filters, you can't do it from a centralized location in a push-based method because the RPC interface can only be interacted with from the local system. You can't do a remote RPC connection for that base filtering engine RPC interface. And this is why from the deployment methods, we've used methods like NetSH because those operate from a local context when deployed through GPO. So when you run NetSH through your GPO startup script, it's NetSH running in the local context, not remotely against that target. Lastly is that because auditing is so important for this type of deployment, you need to have good auditing so that you know the extent of what the blocking is going to be. You're very heavily dependent on your ability to collect Windows logs from your endpoints. And this can be a non-starter for a lot of folks because they have a lot of maybe nomadic clients, maybe their user workstations aren't on an always-on VPN, or they don't have a WEF or WEC collection mechanism set up or some other way to collect Windows logs from their disparate endpoints. And so it can be a non-starter for those scenarios because you need to have those strong auditing capabilities. Otherwise, you're going to be in a scenario where you're blocking things and you don't know why they're being blocked or why these mechanisms aren't working, but they're realistically being blocked by your RPC filters. This is less of a concern if, say, you're implementing this in a data center where you just have a lot of Windows servers and you can strictly control them. You have a good way to pull Windows logs from them. It's less of an issue, but it's definitely a strong consideration to make when you're deploying RPC filters. Is it's heavily tied to your ability to collect Windows event logs. And so that's my talk about RPC filters. If you're interested in the slides, you can go to this GitHub Security Risk Advisors. I'll upload them later tonight. You can also, again, hit me up on Twitter. Here's my handle. And this QR code will take you to the link, so just keep it in mind. But thanks, everyone. If you have questions, let me know. Or if you want to come up and talk to me later during the day, feel free. But thanks for attending. Thanks. Thanks. Sure. Yep. I don't think it says either of those, but you would know because they're both implemented.
Your rule set, you can say,
Yeah.
like, oh, I know this one is supposed to be blocked. But so that's the only way to kind of log that. RPC
Yeah, it
call
doesn't
is
say.
issued.
It doesn't say that it was.
Success or failure. It
Yeah.
just says like RPC call.
Yeah. Here, I can pull up the event log. Yeah, this is the entire event, so you don't get the yeah. It's something. Yeah. 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 Thanks. Hey. Yeah. Yeah. Yeah, see here, I'll pull up the slide. Yeah, so this is the Microsoft link if you're interested, but it's the comprehensive guidance for blocking MSO8. And as part of the workarounds, if you can't apply the fix, they mention this. You might, I'm not sure how commonly this what? Yeah, it came out forever ago. It's patched. Yeah, I mean, for this, it's a very nuclear approach of essentially just blocking all of the RPC traffic entirely for MSO8. So it might be a bit much, but it's definitely an option that Microsoft provides.